Hello and welcome to our Spaceworkers Live event. In this session, we will explore the work we are doing to integrate Alcatel-Lucent OmniSwitch with the Nutanix hyperconverged solution. Here's the agenda. I'll start with a brief introduction to Nutanix and their Technology Alliance program. After that, I will explain the Nutanix plugin, which integrates both solutions. I will demo it, and I will close with key takeaways. Let's begin.
Nutanix is a market leader in HCI, that is, hyperconverged infrastructure. What is HCI? It is an all-in-one solution, a software-defined solution for data center. It combines virtualized computing, that is, the hypervisor, storage, and networking in one package. It reduces the complexity and the cost of dealing with multiple solutions. We've been working with Nutanix as part of their Technology Alliance Partner Program. You can visit the Nutanix Elevate Technology Alliance portal and you will find the Alcatel-Lucent Enterprise landing page together with the Nutanix Ready logo. This is the first milestone in this relationship, but there's more to come. What we're working towards is the top level of certification, which is the Integrated Certification logo. And this is much more than simply certifying that the products are compatible and interoperate. It means that they're truly integrated through the use of APIs and that both vendors can offer a differentiated and integrated solution. The plugin that implements this integration is not a GA product yet. Since this code is not GA yet, when you go to the ALE landing page on the Nutanix Alliance website, you will not see the integrated logo nor the exact details of the solution, hardware, and software. Once we release the GA version of the code, we will complete the requirements of the integrated level to earn this new logo, and we will list the exact hardware and software versions, plus we will provide a technical brief for the solution. For now, the logo that you will see on the landing page is the Ready logo that you see on the screen now. And by the way, the link is provided on the right-hand side of the slide. Let's talk about the plugin. The Nutanix plugin is an additional AOS package. It's similar to the OVSDB package if you're familiar with it. It integrates with Prism, which is the Nutanix management solution. The plugin implements API-level integration. It works in both push and pull mode. When the switch boots up, the plugin software pulls network configuration from Prism and bootstraps the switch configuration to match it. In addition, when the administrator makes changes configuration from Prism or when other events happen such as a VM migration, Prism pushes those events immediately to the plugin such that the required changes can be made on the fly. The plugin also processes some other internal events generated directly by the switch to provide a plug-and-play experience. It can detect when a new hypervisor is connected, disconnected, or moved, or when LACP is configured and adapt to the change. Through the API, it can learn the VMs which are connected and running on each hypervisor and create and tag the required VLANs where needed, as well as the IP interfaces to act as gateways for those virtual machines. So, what are the benefits of this integration? Firstly, it provides automatic discovery and attachment of Nutanix cluster nodes. Second, it provides automatic service configuration for virtual machines. The data center administrator can perform the virtual network configuration directly on Prism, and the network will learn and automatically adapt to it without further intervention. In this way, Prism becomes a single pane of glass for the entire data center. Third, this automation extends to IP routing also. We're not merely talking about VLANs here. It automates the creation of VM default gateway interfaces and routing. Lastly, it also provides VM-centric show commands to add visibility into the virtualized environment and help troubleshoot. So, with this integration, we achieve a centralized network orchestration through Prism and distributed control as the control plane remains on the switch. Here we see a sample topology using a span and leaf architecture based on virtual chassis. It could also be a smaller network comprised of a single virtual chassis. We provide automatic hypervisor discovery through LLDP and automatic attachment through LACP. This is leveraging existing IFAB functionality, but what the plugin does is augment information gleaned from the network with information obtained through the API. So with that, the network can learn all the details of the different VMs that are running on the different hypervisor nodes and map them to the right VLAN. Whenever there is a change in network or VM configuration, the network will be immediately notified and change whatever needs to be changed. In particular, it automates vMotion. It tags and untags VLANs on the fly as needed on VM migration events. It also automates the creation of VM default gateway interfaces and routing between the different application tiers or subnets. Running this plugin in a virtual chassis provides high availability because in case of master unit failure, the plugin simply restarts on the slave and there is no service disruption. So with this introduction, I will show you a brief demo. The code I'm showing is POC code. It's not the GA package. The GA package will come later this year or early next. So let's have a look at it. I'll start the demo by reviewing the configuration from Prism, which is the Nutanix management platform. As you can see, or you could see in the bottom left corner, what I'm running is the Nutanix Community Edition. So I'll start by reviewing the cluster. So for that, I go here to Hardware. And what we see is that I have 3 hosts in this cluster. Each host has 2 network interface cards. And in the network, I have a single virtual chassis of 2 6900s. So each host is dual home to both units in the virtual chassis. And those 2 links are not currently configured as a link aggregate. So they're simply doing NIC teaming. Next, I want to review the network part. So for that, I can go to Settings. And if I click on network configuration, we see that I have 2 virtual networks, a web tier and an app tier. And the web tier is mapped to VLAN 1010, whereas the app tier is mapped to VLAN 1011. We can define more than just the VLAN. In fact, we can define all the IP parameters, even DNS, and it's also possible to run a DHCP server right inside the hypervisor, which I'm doing. So I have created a DHCP pool, and this means that every time I launch a new VM and I attach that VM to one of these virtual networks, it will automatically receive a DHCP list. Next thing I want to review are the VMs that are currently running in this cluster. And so I have these 3 VMs. So I have one web VM, which is mapped to the web tier. I have an app VM, which is mapped to the app tier. And then I have a template VM, which is not currently mapped to anything. And you can see that actually, because in those tiers I'm running DHCP, or I'm running DHCP inside the hypervisor, those 2 VMs, they automatically have an IP address. So that's about everything that I want to show you right now. What I want to show you next is what happens when we look at it from the switch. So let's see it from the switch console. I have it right here. I want to start by showing you that these are 6900s T40, and this is the software release I'm currently running. The other thing to show you is that this is a virtual chassis of 2 units. And the last thing I'm going to show you here is that currently the only package that I'm running is the Nutanix plugin, but currently it is stopped. Before I started, I want to review a couple of things. So first, let's do a show VLAN. And as you can see, I only have VLAN 1, which is the default, and 494, which is used for virtual chassis communication. So only the default configuration. If I do a show IP interface, I only have the EMP IP interfaces, I have the loopback IP interface, and then I have the management IP interface, which is the interface that the switch is going to use when communicating with the Nutanix cluster. So now I'm going to start the plugin. So for that, the command would be app manager, start AMS Nutanix plugin. And so we're going to give it a little bit of time for it to start. And now let's check if it's actually running. So I'm going to repeat this command and we see that it is running. So now it started. So now it went and it bootstrapped the configuration from Prism. So now if I repeat the same show VLAN and show IP interface commands, I'm going to see that we now do have some configuration that we did not have before. So let's do a show VLAN. And as you can see, I have two more VLANs. So one is for the web tier and the other one is for the application tier. If I do the show IP interface, I have two IP interfaces, which are the gateways for both application tiers. And of course, the VLANs are mapped on the ports that lead to the hypervisors that those App1 and Web1 VMs are currently running on. So we can actually verify that using the Nutanix CLI. For that, I can do Nutanix CLI, and we start actually with show host. So remember I explained we have three hosts. Each host has two cards. And so let's take the first one. What you see right there is the name of the host, which is a default. The unique identifier, the type of host is Nutanix AHV, the management IP for the host, the MAC address, the Ethernet 1 NIC card, and what port it is connected to. So there's also another NIC card for the same host, which is down here. And so you see that that NIC card, which is the Ethernet 0, is connected to port 2137. Next one is I can do a show network. And here we see the two networks that we define within Prism, the web tier, the app tier, with all the VLAN and IP related information, including the Dhcp server and the Dhcp pool. And then the last one is show VM. And here we see the two VMs that have NIC cards attached, because I have a template VM, but that one doesn't have a NIC card attached, so that's why we don't see it. So App1, Web1, with their MAC, their IP, what network they are attached to, web tier and application tier, whether they're connected, powered on, what VLAN they're attached to, what interface they're coming from, and what host they're running on. Okay, so the next thing I want to do is what happens when I add a new virtual network within Prism. So let's do that. Let's add a virtual network for a database tier. So we go back to Prism and I go to settings and let's create a new virtual network. So we click on create, we give a name of database tier. For VLAN, I'm going to choose 1012. I will configure the IP part, so I'm going to choose subnet 10.10.12.0/24. For gateway IP, I like using .254, so let's do that. I'm not going to bother with the DNS part, but I will configure a Dhcp pool such that when I attach a VM or when I launch a VM into this tier, it gets an IP address. So for the scope, I'm going to go with 100 through 200. Click on submit, click on save. And so now this is being registered in the Prism database, and in turn Prism is going and talking to the switch and telling it that now it needs to add an additional VLAN and an additional gateway interface for this new tier. So let's verify that. I can do a show VLAN, and you see there's the new VLAN there. I can do a show IP interface, and we have it right there. It's currently down because I don't have a VM attached to this VLAN yet. We're gonna do that next. I can repeat one of the other commands. So if I do the show network, we see that now the database tier is visible. Okay, so the next step would be to actually launch a VM and attach it to this database tier. So I'm going back to Prism. Let's go to VMs. I'm not going to provision the VM from scratch, so that's why I have this template. I'm simply going to edit it. Let's give it a name of DB1. I'm going to add a NIC card. I'm going to attach this NIC card to the database tier which we just created. Click on Add. Click on Save. And we're good. So now I will launch a console. And let's ping one of the other VMs. So let's verify what are the IP addresses of the other VMs. So let's say for the web one, it's 10.10.10.162. So I already had it there. Let's repeat that ping. And as you can see, I can do all the configuration from Prism without having to do any configuration on the switch. Of course, I can also ping the other one. What is the IP address? 10.10.11.155. And of course that works. So I just showed you how the switch can bootstrap its configuration from Prism. I showed you how you can make a change in Prism, define a new network. You can launch a VM into that new virtual network, and then the switch will automatically adapt to that. Then the last thing I want to show you is let's do a VM migration. Before we do that, let's verify something from the switch. So let's go back to the switch console. So let's do show VM. And let's imagine I want to move the web 1 VM. As you can see here, each VM is running on a different host. So that means that when I move the VM from one host to another, I can remove the VLAN tag from the port that was leading to the old host. On top of course, adding it to the port that's leading to the new host. And in doing that, we help keep broadcast domains as small as possible, which will optimize the performance. So if the web 1 is VLAN 1010, I should have this one tagged on the two ports that lead to the hypervisor that VM is currently running on both ports, not a single one, because of redundancy. So let's verify where we have VLAN 1010 tagged. So we do show VLAN 1010 member ports. And so you see these are the two ports. 2137, which we see there, it's the currently active port for this VM, and 2135, which is currently standby for this VM. So let's now migrate this VM. So we go back to Prism and I click on migrate. I will let it choose what host to migrate it to, and then we're just gonna let it do the migration. Okay, the migration is now finished. If I go back to the switch, well, we see information saying that now the ARP information has been overwritten, and that's normal when you do VM migration. And let's now check what ports VLAN 1010 is now tagged on. And as you can see, these are different ports. So it's 1135 and 2137, whereas these were 1137 and 2135. So, well, as you can see, we not only can react to new virtual networks being created from Prism, we can react to any other change related to the virtual machines, but of course we can also properly react to VM migration events. So that brings me to the end of this demo. Let's wrap it up with some key takeaways.
Through this plugin, we bring a unique and differentiated value proposition to our joint customers. Both our solutions will be not just simply validated, but deeply integrated, which increases the value of the combined solution. Lastly, through this plugin, we achieve seamless orchestration and integration through a single pane of glass management interface. That brings me to the end of this session on the Nutanix Technology Alliance and Integration. I hope you found it useful. Keep enjoying your Spacewalkers Live event. I'm looking forward to interacting with you on this and other topics on the Spacewalkers platform. Take care and see you soon.